Remember, we've got the rules, energy principle, work energy theorem, all of that, but the question will direct to how do you use it. In this case, we're going to use energy principle. That is how they want to do. Then we're going to do it. Then we say delta EP plus delta EK equal to 0. Remember, the delta is change in physics. So that means you're going to have mgh final minus mghi plus half mv squared final minus half mvi squared. This will be equal to 0. This is the formula you can use in the energy principle. There is the other formula, but I'm not going there. I just want to show you this one. Right. Here what is happening is the mass was given as 5 kilogram. So you say 5. Remember, G is always 9,8 is also on the formula sheet. 9,8, and then the final height was 5 minus 0. I will explain why it is 0 here. Plus, the 0 is always, there is no height at the bottom. So obviously the height will be 0. But once you lift it or you go a little bit up, then you will have the height. So in this case, the initial was 0. Then you have the 5 minus 0. Plus the half multiplied by your mass. The mass is 5. And then you want that final velocity. Minus the half into the 5, and then the 0 squared, then you have the 0. That is how you're going to solve the question. That is how you do it. And then this is the velocity that you need, the final velocity. You work it out until you come to the final velocity, which will be 9.09 meter per s. This is the answer that you're going to get. Number 2, the reason is there is no friction. That is the reason why kinetic energy at point P is the same as the kinetic energy at point Q. The reason is because there was no friction or 0 resultant for a force. A force for which the work done is path dependent. That is WNC. That is the meaning of work WNC. That is the meaning of the WNC. The WNC, it means a force for which the work done is path dependent. You can also go and learn from the books because this is a book work that you can read. The WNC equal to delta EP plus delta EK. Remember, they ask you WNC in number 3. So the question carry over to number 4. So there is your work non-consecutive force. What is work non-consecutive force? It's also frictional force, delta X cos theta plus. What is delta EP? That is potential energy. You have mgh final minus mgh initial plus half mv squared final minus half mv squared initial. This is the scenario that you have. What are you looking for here first? Remember, you want angle, but you must first find x. It was not given. You must first find this x. The x was not given there. So we have to find the x first. Once we find x, then we can find the angle that they want. This is what you have to do. Let's substitute. Frictional force was given, it was 8. We still need the delta x, and then cos 180 degrees. Remember, the cos is 180 because it's in the opposite to the motion. That's why we put cos 180 degrees. And then now we come to delta EP. In the case of delta EP, what you can do before you solve is, I'm going to put it easy for you so that in exam you don't have to struggle. You can easily say mg brackets final minus hi. Why? Because mass and gravity will never change. What is changing there is only height final and height initial. Same with this side. You can say half m v squared final minus vi squared. The mass cannot change. What is changed is only the velocity. Here, the mass cannot change, the gravity cannot change. What is changing is the height. Therefore, what is your mass? Your mass was given as 5. And what is your G? 9,8. And what is the height final? It was 5 minus 0 plus half 5, and then the final velocity. Remember, we have calculated final velocity at P in number 3. Then now in number 4, what are we doing? We are taking that final velocity, it becomes now initial. I want to explain this because it's very interesting. Say this is the object at rest, is 0, vi 0. The object moves with velocity, I'm just giving an example, 20 meters per second. Now you have initial 0, final is 20 meters per second. Now you change from the final and you stop now. That final velocity become initial, and when you stop is final velocity now. Which means the previous problem we had 9.09. What was 9.09? It was a final velocity at P. Now from P up to the incline or to Q, that V 9.09, which was final velocity, now become initial velocity. You must remember that. Therefore, we're going to have 0 squared minus 9.09 squared. There you are. I hope you got what I was explaining. You can take an example when you drive a car. The car is at rest, you move the car, you drive a speed of 100 kilometers per hour, that will be final velocity. And then you change to 120 kilometers per hour, that 100 become initial, 120 become final. And you stop. When you stop, that 120 now become VI, and then when you stop, become V final. It's very interesting. Right. Now, after you work it out, then you will find your delta X to be 5,4458 meters. Remember, we didn't answer the question. We want theta, which is our angle. But what we did here is we first find delta X. Sorry, I must put delta X here. This is what I'm solving. I'm solving this delta X here. Now, after I find delta X, I go to my diagram. Then I say sine theta equal to my height, which is my opposite, is 3 over, this is my delta X, 5,4458. And this will become, you press your calculator and then you get your angle to be 33,43 degrees. And then you have answered the question. It's a very interesting question.